Okay, so let's check the BGP messages. We can see that we can have open, update, keep alive, notification and the refresh message. On all BGP messages we'll have the BGP header, and this is how the BGP header looks like. We'll have the marker field, length and type. The marker is a 16-bit field message using to delimit the BGP messages. Length indicates the length of the message, and type indicates the type of the message. It can be open, update, keep alive, notification or refresh. So in this case we'll check the first BGP message, which is open, and open is generated after TCP three-way handshake is completed, and it is sent to both peers and it is used for relationship establishment. So in the open message we'll have version, autonomous system, hold time, BGP identifier, optional parameters length and optional parameter fields. Version will indicate the protocol version. It can be IPv4 or IPv6. Autonomous systems indicates the autonomous system number of the sender. Hold time is a proposed hold time which is negotiated afterwards. We'll have the BGP identifier, which is the IP address configured for BGP peering. Optional parameters length is self-explanatory, and optional parameters in TLV format, as we saw in ISIS. It is used for protocol extension and additional functionality. Update message. As we can see, it will also have the BGP header. Update message is used to exchange routing information between peers, and it is used to advertise and notify that some routes are no longer advertised. So this message is used to share routes, and if a route is no longer present, it will be removed and will no longer be advertised. As fields we have unfeasible route length, which is the total length of the withdrawn routes. If it is 0, no routes are withdrawn. Withdrawn routes is the list of the routes which should be eliminated from BGP. Total path attribute length represents the total length of advertised routes. Path attributes are sent for each route, and RLI is a list of the new routes being shared. We also have the keep alive message, which is used to maintain the BGP neighborship. It is just a BGP header with no additional fields. We also have notification, which is used to send an error notification. After sending it, the BGP peer is turned down automatically. So when we see notification in our logs, it means that something is wrong. So notification message have the error code field, which represents the type of notification. Informs the peer if the error was on open message, update message, BGP header, and if the hold time expired, and so on. Error subcode is more specific error information, and a data field, which is used for reason diagnostics, and data field is variable in size and it depends by the type of error. We also have the refresh message, which is used to request information about specific address family, and we have the AFI field, which is the address family identifier, can be also IPv4 or 6. We have the reserved field, which is set to 0, and for now it is not used. And SAFI is the subsequent address family identifier, can be unicast or multicast. Now that we saw the BGP messages, we can see how the BGP peering is established. We can have 6 neighbor states. The 3 of them represents the TCP connection between neighbors, and 3 of them represents the BGP connection between members. Idle is the initial state where the BGP is configured but no connection has been initiated. We'll have connect, which means that the local BGP peer is initiating a connection. If the local peer initiated a connection which is successful, it will send the open message, and after sending the open message, the peer will transition to open state. If the connection will fail, local BGP peer will start listening from connection requests sent by its peer and will transition to active state and will stay in the state until connect retry timer expires. After the connect timer expires, it will try again to initiate another TCP session. In active states, after the three-way handshake is completed, the local peer will send again open messages, and after the open message is sent, the peer will transition to open send state. We have a possibility for the peer to be stuck in active states, and in this case you should check the connectivity interfaces, maybe routing on the local device. Open send is when the local peer sends an open message and it is awaiting for the open message from its peer. When an open message will be received from one peer to another, BGP will check for errors. If there are no errors, received peers will exchange keep alive messages, and if there are errors detected, the local peer will transition to idle state and will try to initiate a connection again. Open confirm. Local peer will wait for the keep alive or notification message. If no keep alive is received within the negotiated timer, local peer will send a notification message stating that the whole timer expired and they will transition to idle state. If the local peer received a notification message, it will transition to idle. If the local peer will receive a keep alive, it will change its state to established. And established is the state where the BGP is up on both sides, and at this point update notification and keep alive messages will be exchanged, and the connection will be torn down when no keep alive message is received within the negotiated hold time or when a notification message will be sent. So on a quick side note, like I said, you can find the video series links in the description and you can watch these videos chronologically. You can also hire me on Fiverr. I offer consulting and design services, troubleshooting and whatnot. And if you want to follow along with my Udemy courses, you will also find the discount codes in the description. Thank you, and I will see you in the next one.